Okay, and then the other one we have. Introduction to patterns and functions. Write a rule for the function from the data set. Okay, I didn't give you a lot of workspace here. So you make a line. E is what you're equal to. It's not equal to Y. Well, you know E starts at 30,000. Then from there it changes, so you add times M. Now, the key is finding your rate of change. So here's what I do. You take 27,000 minus 28,000 from the bottom. You get negative 1,000. But at the same time, you have 6 minus 4. That's 2. So you set up negative 1,000 divided by 2. Then I go back up here. 28,000 minus 29,000. That's negative 1,000 again. 4 minus 2 is 2. So negative 1,000 divided by 2. Okay, 29,000 minus 30,000 is negative 1,000. But while that's going on, the minutes, 2 minus 0 is 2. So it's negative 1,000 divided by 2. Okay, divide all those. They're all the same, so it's going to be negative 500. Okay, that's your rate of change. And you have your equation. 30,000 plus negative 500 times M equals E. So you're making the line, you just use different variables. Okay, Toro, the function is linear or nonlinear. So, I take 2 minus 5. It's going to be negative 3 because you went down 3. 3 minus 2 is 1, so it's negative 3 over 1. 5 minus 7 is negative 2, that's 1. Right away they're different, okay? So it's nonlinear. Wait a second, I messed that up, my bad. I want to redo this. I want you to switch something, please. I want you to make that a 4 and that a 1. 10, 7, 4, 1. Okay? 10, 7, 4, 1. Then let's redo it, sorry. 1 minus 4 is negative 3. 3 minus 2 is 1, so you put negative 3 over 1. 4 minus 7 is negative 3. 2 minus 1 is 1, so negative 3 over 1. 7 minus 10 is negative 3. 1 minus 0 is 1. It's the same ratio throughout the table, so that means it's linear. Okay? Okay, now the next one. 20 minus 8, that's 12. 3 minus 2 is 1, so that's 12 over 1. 8 minus 1 is 7. 2 minus 1 is 1. Right away we got two different ratios, so I don't even need to do the last one. I know it's non-linear. Okay? Okay, a store sells flowers for $1.50 each. There's a limit of 7 flowers purchased. What is a reasonable domain and range of this situation? Tell her the function is continuous or discrete. So you're going to want to make a table, an XY table, and you have dollars and flowers. Remember, dollars can never be X, it has to be Y. And then go 0, 1, 2. I usually like to go 3 on this, that's just me. So if you buy 0 flowers, you don't have to pay anything. If you buy 1 flower, it costs $1.50, so put times 1.50. That's $1.50. If you buy 2 flowers, it costs $1.50, so 2 times 1.50, and that's going to be $3. 3 times 1.50, that's going to be $4.50. Now, after you get through 3, there's a limit. The limit is 7 flowers. So if there's a limit to flowers, there's going to be a limit to your dollars. That's how a function works. So 7 times $1.50 is $10.50. Okay. Okay, so the domain goes from 0 to 7. And the range goes from 0 to $10.50. So that's your domain, that's your range. Now, is it continuous or discrete? Now, remember how to determine that. Pick a decimal, 2.5 or 1 point. Just pick, let's go with 2.5. Is it possible to go to a store and say I want to buy 2.5 flowers? It's not. They only come by the whole, so that means it's discrete. Decimals, that would make sense, means it's continuous. Okay, graph the function using a table. Y equals negative 3x plus 1. So we make a table and just put values from 2 to negative 2. Integers from 2 to negative 2. That's good enough. You can keep going, but yeah. So, y equals negative 3 times x plus 1. So to find y, I write out the expression negative 3 times x plus 1. I'm going to go like that. You can. And then to find what y equals, you simply input 2 in for x. Okay. So you take negative 3 times 2 plus 1. It'd be negative 5 because you'd have negative 6 plus 1 is negative 5. Okay, so 2, negative 5. So this is x, this is y. 2 on x is 1, 2. Negative 5 on y. I don't care if you number them or not, but you got to know where the point's at. So 2, negative 5. I will label them, you don't have to, okay? Okay, now I put 1 in. So negative 3 times 1 plus 1, negative 2. So 1 on x is here, and then negative 2 on y is there. 1, negative 2. Now 0 goes in for x. It's going to be 1 because 3 times 0 is 0. So 0, 1. So 0 on x is here, 1 on y is here. Okay, then negative 1. Negative 3 times negative 1 is 3 plus 1 is 4. So I go to negative 1 on, now negative 1 on x is here. Okay, positives, negatives. Okay, so negative 1 and then 2, 3, 4. I don't care if you draw these numbers, you got to get the point in the right place. So, and then negative 2, so negative 3 times negative 2 is 6 plus 1 is 7. So x is negative 2. So on the x line, negative 2 is here. On the y line, 7 is going to be all the way up here. Okay. Now, you need to connect those points because it is a continuous graph, and it can keep going that way and that way. Okay, 6. Tell whether the graph represents a function, vertical line test. It can't go through more than one at a time. So 1, 1, 3, that's a non-function. Okay, again, this is a set of discrete points. 1, 1, 1, 1, 1, 1, 1, that's a function. Okay, this is a continuous graph. You just pick somewhere to make one vertical line. How many times did it cross? Once. So that's a function. If it would have crossed it twice, it would have been a non-function. Okay, identify the domain and range of the function. Tell whether or not the pairing is a function. So, these are your coordinates. xy 9, 3, xy 4, 2, xy 1, 1, xy 0, 0. So, domain, range. The domains are all your x's. So, 9, 4, 1, 0. Now, you're ready to tell whether it's a function or not because it's all based on the domain. Do you have any repeat numbers in the domain? You don't. They're all different, so that makes a function. The range I want you to list, the range never determines whether it's a function. You just go 3, 2, 1, 0. So go domain, then determine whether it's a function or not, then your range. Okay, next one, 4, 5, negative 5, 3, 10, 2, negative 5, 2. So domain 4, negative 5, 10, negative 5. We have a repeat of negative 5, so that means they would cross it twice, and that's a non-function, because you have this repeated value. And then the range 5, 3, 2, and 2. Okay, last problem. Number 10. A team of divers assemble at an elevation of negative 10 feet d. The elevation of the team decreases at a rate of 50 feet per minute m. Write a rule that represents this situation. So let's make a line. Equals, and we're going to put d here at the beginning, at the end, whatever comes first. Okay, they start at negative 10. You can start at a negative. And then they're adding. Now it's decreasing by 50 feet per minute, so it's decreasing. You have to make your 50 into a negative. Okay, negative 50. You got to read the problem. It's decreasing, it's negative. Feet per minute, so it'd be times m. And there's your equation. So negative 10 plus negative 50 times m equals d.